Last example of triangle problems and identities. Given sine theta equals 63 over 65 in quadrant 2 and cosine beta equals negative 7 over 25 in quadrant 3, find sine 2 beta, cosine 2 beta, sine theta plus beta, and cosine theta plus beta. Okay, let's draw our triangles. Make sure you pay attention to which quadrant they're in. 1, 2, 3, 4. So theta is in the second quadrant. You have to draw your triangle and your theta against the x-axis. 1, 2, 3, 4. Beta is in quadrant 3. Draw your triangle and your beta against the x-axis. All right, label your triangle. The SO fraction tells me this is 63 over 65. The K fraction tells me this is 7 over 25. Use Pythagorean theorem to find your third side. You should get that A equals 16 for the theta triangle, and B equals 24 for the beta triangle. Since we're on the coordinate plane, we need to pay attention to plus and minus signs. So from my origin, I go backwards 16 and up 63 to get to the tip of the triangle, backwards up, and the hypotenuse is always positive. From the origin, I have to go backwards and down, which are both negative directions, and the hypotenuse is always positive. All right, now my triangle is set up. Reminder, I am using these steps right here. All I have left to do is write out my identities and replace them with their SOHCAHTOA fractions. Here are the identities that we are using: double angle and sum and difference. Okay, let's start with sine of 2 beta. Beta, so we're using this triangle here. So sine 2 beta is 2 sine beta cosine beta. Replace sine beta with its SO fraction. Replace cosine beta with its K fraction. If you need to write 2 over 1, you can. And now you will multiply every single thing together across the top to get 336, and multiply everything together on the bottom to get 625. If you could simplify that fraction, simplify it. In this case, it doesn't simplify. It's positive because this double negative cancels each other out, or double negative is positive. All right, we also can figure out what our cosine fraction is, cosine 2 beta. I'm writing it here, but it's dealing with this triangle, the beta triangle. And you can use either of those 3 cosine identities. I'm going to use cosine squared beta minus sine squared beta. Replace cosine with its K fraction. Replace sine with its SO fraction. Square everything. So negative 7 squared is 49 over 625. Negative 24 squared is 576. It's a 7 over 625. They have the same denominator, so I can subtract negative 527 over 625. Before we move on, let me mention if I wanted to know what quadrant 2 beta is in. So beta is right here in the third quadrant, but if I double that, which quadrant is it going to end up in? Probably somewhere 1 or 2. You can look at the signs here, plus or minus signs, and use all students take calculus. 2 beta has a positive sign value, so it's in one of these quadrants, but a negative cosine value, so 2 beta is in the second quadrant. Just side note. Okay, let's continue to do this with now where I'm going to add my triangles together. So we need to write out our identity. Replace sines and cosines with their SOHCAHTOA fractions. Make sure you pay attention to which quadrant you're in. Sine of theta is 63 over 65. Cosine beta, negative 7 over 25. Sine beta, negative 24, 25. And cosine theta, negative 16 over 65. Simplify your fractions or multiply across the top. So this is negative 441 over, multiply across the bottom, 1625, plus double negative multiplies to be positive, 384 over, multiply across the bottom, 1625. They have the same denominator, so I can add that together. And you end up with negative 57 over 1625. If you can simplify your fraction, simplify it. This does not simplify, so that's it. I can also find the cosine theta plus beta fraction. If I do cosine theta cosine beta minus sine theta sine beta. Replace them with their SOHCAHTOA fractions. Pay attention to which triangle you're looking at. Cosine theta is negative 16 over 65. Cosine beta, negative 7 over 25. Sine theta, 63 over 65. Sine beta, negative 24 over 25. Sorry. Multiply everything together, so multiply across the top and multiply across the bottom. And then in your second fraction, minus, this will be a negative fraction, minus a negative ends up making this positive. And now they have the same denominator, so I can add them together. Oh, and simplify your fraction if you can. It happens to be 1.